All right, so I believe I'm recording. This is a practice review of the law of cosines and the law of sines. Just a couple of examples to go through it, and hopefully you guys will be able to see my calculator once I do my screen sharing, so you can see those pieces as well. I believe that Delta now has help videos up as well, so I figure if one video doesn't make sense, sometimes it helps to watch a different video. Mr. Delta might explain it in a different way than I do that might make more sense to you. Or maybe I explain it in a way that makes more sense to you until you say, forget Mr. Delta. So in any case, we're starting here. And we want to recall what those two laws are. So we've got the law, in this case, the first one is the law of sines. That is what we covered first. And then second, we've got the law of cosines. And the law of sines states that if you have a triangle, so let's say you got triangle ABC, and then obviously the opposite sides are going to be the lowercase versions. If you've got that triangle ABC, there's just some equivalence here that states that, in this case, the sine of A over the corresponding side length, the one across from it, A, is equal to the sine of B divided by lowercase b, and that's equal to the sine of C divided by lowercase c. Now, a lot of times we only use 2, or we only use these two, or the outer two. But there's another way as well. If I'm trying to solve, right, a lot of times we're only ever going to use these law of sines and law of cosines to find missing side lengths on triangles, or to find missing angles on triangles. So in this case, we've got, when you have sine of A, right, when you have the angle, right, capital A refers to the angle A right here. So when you have the angle in the numerator, that's the way you want to set it up when you're trying to solve for an angle, because it's going to be way easier, and you'll see it in a minute. It's only going to require 1 step or 2 steps for us. And then when you're trying to solve for a side length, we're allowed to flip it. We're allowed to say A divided by sine of A is equal to lowercase b divided by the sine of B, and that is equal to lowercase c divided by the sine of C. We're allowed to do that. And secondly, the law of cosines is referring to the same situation here, right, with this triangle. Only it's its own law. And when I say law, I mean, you know how you've got the quadratic formula? This is a type of formula, but the name of it says it's a law. So bear with me. The law of cosine states that c squared is equal to a squared plus b squared. That should look familiar to you, right? That's the Pythagorean theorem. However, these triangles don't have any right angles on them, so we can't use the Pythagorean theorem unless it has a right angle. So there are some things in math land that we need to do to compensate for that, and that is by subtracting 2 times A times B, right? They match up with what is already on that same side of the equal sign. And then that's going to be multiplied by the cosine, because it's the law of cosines, times, the cosine of the angle that corresponds with over there. So that would be capital C. These two laws, or rather jumbles of symbols, are what we're going to use in the following way. So the next page, on delta, we've got, in this case, the law of cosines, and they say side angle side, because that's how the triangle is set up, and I will show you that in a second. So they say that we've got triangle KLM. So we've got triangle. Oops. That looks a little bit too right. Triangle KLM. And we know that side length K, not angle K, side length K is equal to 4.4 centimeters. We know that side length L is equal to 3.1 centimeters. And we know that angle M is 150 degrees. So this is why they say it's the side angle side setup, because we've got a side, an angle, and a side. Think back to core 1, side, angle, side. When we've got side, angle, side, they are telling us to find the length of M. Well, M is across from angle M, so M is going to be right here. But we don't know what M is. So we need to use the law of cosines. So refer back to what this law is. C squared equals A squared plus B squared minus 2 times A times B times cosine of C. In any case, we could swap this and make it become A, B, and C, but it's okay. I always just treat it in the order. KLM is going to be the same thing as A, B, C. So we'll just treat it like that. Now, what is unknown, though? That's what always starts our formula. That's where we always start. So looking at our specific triangle, we don't know what angle M is. And so that's what I'm going to put over here. M squared. That's what we're starting with, right? We start with what's unknown, what we're trying to find. And then we go from here and we say equals. We've got, in this case, our other two sides are K and L, and those are the remaining sides, so we should use them. So that's 4.4 squared plus 3.1 squared. And then that's going to be subtracted, so minus 2 times 4.4 times 3.1. And that is all going to be times the cosine of, sorry, I ran out of room here, cosine of 150 degrees. Let me see if I can move this image to the side a little bit. We will slide that over for the time being. If I need to get back to it, I think I can. So in this specific problem, now that we have it set up, it's a matter of just solving this all out to make it into one solid thing. If you want to, you can plug it into your calculator. So that's what I'm going to do right now. So I have this screen on my iPad right now, so I can track it. But what I'm going to do is share my screen with my calculator. Or maybe I could do my desktop. Calculator, here we go. And you hopefully should only be seeing the calculator, not my email. But anyway, so we've got 4.4 squared plus 3.1 squared minus 2 times 4.4 times 3.1. And then that's going to be multiplied by the cosine of 150. And from here, I'm going to hit enter, and I get the number 52.595. So 52.595. All right, let's go back to my iPad a minute. This might get a little bit tricky. And there we go. So 52, this is what we get. We get m equals 52.595. And we're trying to solve for m. So what do I need to do to both sides to get m by itself? I should take the square root. So if I'm taking the square root of both sides, I end up with, in this case, second x squared. So 52.595. And I get 7.252. And they want us to round to the nearest tenth. So that would be to 1 decimal point. So that'll be 7.23 if I round up appropriately. So m equals 7.3. And that is my solution. So that's what I would type over here, 7.3. I'd put that in my delta answer and I'd hit enter. Now, don't freak out if they tell you it's wrong. A lot of times, it's just a matter of how you round it. And so it's possible you're doing everything right. It's just you're rounding it incorrectly. So we've got 7.3 as our answer. Let's move on to another example. So let's look at our triangle. We've got, in this case, triangle OPQ. Triangle OPQ, which means that this is going to be a lowercase p, this is going to be lowercase q, and this is going to be lowercase o. And they tell us that side length O is equal to 700 centimeters. That was a bad zero. P equals 840 centimeters. And Q equals 620 centimeters. And they want us to find angle P. So what is angle P? So this is a different situation, but they are still telling us to use the law of cosines. So that is still this guy right here. But we're going to use it in a slightly different way. So if I plug that in, just literally plugging it in exactly, you might be asking, wait, so where do I start it? Well, you always start it with what is unknown. But wait a second, Mr. Dielman, you usually start it with the side length squared, right? C squared. But I know all my side lengths, correct. But notice C here and also cosine of C, they match up. And so we are going to be using, in the end, it's going to say something like times the cosine of, in this case, angle P with a bunch of other stuff. And all that other stuff is determined by what we're trying to figure out. So I'm going to put P out front so that it matches up with the P at the back. So it's going to be 840 squared is equal to the other side lengths. So 620 squared plus 700 squared minus 2 times 620 times 700, and then that is times the cosine of P. That's what we're trying to find, but we don't know what P is, so we're trying to figure that out. On my calculator, I won't show you this yet, but on my calculator, 840 squared is equal to 705,600 600. 620, in this case, squared, is 384. 384,400 plus 700 squared. That gives me 490,000. I think I picked a bad example. This is a really long number, but it's okay. And then minus, in this case, 2 times 620 times 700. So 2 times 620 times 700. And that gives me minus 868,000 times the cosine of P. Now here's where you got to be paying close attention, because I can't just subtract to get P by itself. I obviously want P by itself, but I need to get cosine of P by itself first. So I need to get rid of all this stuff and move it over to that side. And the way you do that is by subtracting. So I'm going to subtract this and this from both sides first, because you need to follow the order of operations, the PEMDAS. From here, we are going to subtract each of those from 705,600, 5,600 minus 384,400. And then I'm going to subtract 490,000 as well. And I end up with negative 168,800. And that equals negative 868,000 times the cosine of P. This is by far the trickier, lengthier process, but we'll get there. How do I get cosine of P by itself? Well, I need to divide both sides by negative 868,000. Divide both sides. I'm going to do a squiggle there. Actually, I'll write it out. Negative 868,000. And that is going to give me, in this case, divided by negative 868,000. That gives me a tiny number. I get a decimal of 0.19447 equals the cosine of P. Now this is where I want to show you guys my calculator, where we got to go for this. And we want P by itself, right? We want to do P by itself. So the way that you do that is you have to take the inverse cosine of both sides. So I need to do cosine to the negative 1 of 0.19447, and also do that to the other side, cosine to the negative 1 of cosine of P. That will cross out, so we're left with P, and then I'm going to get something in result here. So let's go to my calculator again, and you can see all my previous work, but in this case I need to hit the button second cosine to get the cosine to the power of negative 1, and then I'm going to put 0.19447 inside the parentheses, and that's going to give me my angle. And so in this case, my angle is going to be, let's go back to Zoom, or sorry, my iPad. And so we get the angle of 78.786, and they want it to the nearest degree. So that means we're going to round up. So that means that angle P equals 78.78, rounded up to 79 degrees. And I would go back up here and I would write 79 in my answer. All right, I'm sorry, this is getting very lengthy, but hey, it's the process. It's the hard work we got to do to get this right. Last but not least, law of sines. The first page I said, law of sines is, right, it's the sine of an angle divided by its corresponding side, or the side that's across from it. And that's going to be equal to another sine of an angle divided by its side. So let's move to this final one, where we've got triangle KLM, where we've got our side lengths that are going across. And they tell us that angle M is 124 degrees. Angle K is 29 degrees. And we know that side length M is equal to 18 inches. And they want us to solve, they want us to find the length of K. So we're trying to find K. What did I tell you on the first page with the law of cosines? If I'm trying to find an angle, I should put the angle at the top of the fraction to start my formula. Or if I'm trying to find a side, I should put it at the top of my fraction. So let's do that. My apologies. So K. Well, what do I divide K by? Well, I should divide it by the sine of the angle that's across from it, which would be the 29 degrees. So the sine of 29 degrees. And that's going to be equal to some other angle and side pair that we know. And the only other side length that we know is the 18, and it is going to match up with the angle across from it, which is 124. So we're going to do that. So that's going to be equal to 18 divided by the sine of 124 degrees. How do I get K by itself? Well, I need to multiply both sides by sine of 29 in order to get rid of it over here. So what I'm going to do is multiply both sides by 29, or sine of 29, and that'll end up giving me K equals 18 divided by the sine of 124 times the sine of 29 degrees. And what I'm going to do is I'm going to take this and plug it into my calculator. So let's go to the calculator. Let's clear this old work. And we've got 18 divided by, actually I'm going to put parentheses, 18 divided by the sine of 124. Make sure you have proper parentheses. And then we're going to multiply by the sine of 29 degrees. And this will give us our side length, and it is 10.526. So let's go back to our iPad, and we get that angle K, side length K is equal to, what do we say, 10.526. They want us to the nearest tenth of an inch, so that's one decimal. So that's going to be 10.5 inches. And so I would put 10.5 in my box. And that's that. So I know it's lengthy, but I know you can do it. And I'm doing a lot of blabbing and explaining. If I were to just do the work and just plug and chug, it would go a lot smoother and a lot faster. So that is that. I will leave you with this, and best of luck. Thanks for your hard work, everybody.